Have you ever stopped to think about what's actually keeping you alive, like right this second? It all comes down to logistics. It's a constant internal delivery system that's servicing trillions of individual customers, your cells. Today, we're diving into the two incredible fluids that make it all happen: blood and lymph.
So let's start by looking at survival for what it truly is, an absolutely massive logistics problem.
I mean, really think about that for a second. Every single one of your cells needs a non-stop supply of oxygen and nutrients. And at the exact same time, all its waste has to be hauled away. There are no breaks, no holidays. It just has to work. This quote from our source material just nails it, doesn't it? It's not just about getting stuff from point A to point B. It's about doing it perfectly for every single cell all the time. If this system gets even a little bit off, everything just stops. For a simple organism like a sponge, life is easy. It just pulls the ocean right through its body, and bam, job done. But for us, that's not even remotely an option. We need something way more sophisticated. We need a closed, internal, high-pressure network. And that, of course, brings us to the star of the show. Let's talk about the big one, blood. You can think of it as the main, high-speed superhighway that solves the bulk of that incredible logistics problem. Now, I know what you're thinking. Calling a liquid a connective tissue sounds kind of weird, right? But it actually makes perfect sense. See, like bone or cartilage, blood is made of cells suspended in a matrix. The big difference is that blood's matrix is a fluid, plasma, and it's fibrous, which means it flows freely without any tough structural fibers getting in the way. And this really puts it into perspective. Over half of your blood, a full 55%, is that fluid matrix we just talked about, the plasma. The other 45%, well, that's what we call the formed elements. These are the cells and cell bits that are actually doing all the specialized work. So what's actually in that yellowish plasma? Well, it's mostly water, like 90 to 92% water. That makes it the perfect solvent to carry everything else around. But that other little slice is where all the magic happens. It is jam-packed with proteins, nutrients, hormones, you name it. And within that plasma, the proteins are like highly specialized teams. First, you've got albumin, which I like to call the pressure manager. Its job is to keep water from leaking out of your blood vessels. Then you have the defense team, the gamma globulins, which you probably know as antibodies. And finally, you've got the emergency crew, fibrinogen and prothrombin. These are your essential clotting factors for when things go wrong. So here's the key takeaway for this part. When doctors and scientists talk about plasma, they mean the whole liquid package: water, proteins, and those all-important clotting factors. But what happens if you let blood clot? Well, all those clotting factors get used up to form the clot. The liquid that's left over, that's called serum. It's still got all the other goodies: hormones, nutrients, antibodies, but the clotting crew has left the building. The relationship is actually super simple. Plasma minus the clotting factors equals serum. And this isn't just trivia. It's incredibly useful in a lab. If you need to analyze something in the blood, you often use serum so you don't have to worry about your sample turning into a big clotted mess in the test tube. Okay, so that was the plasma, the fluid matrix. Now let's get to the other 45%, the formed elements. This is the specialized workforce out there doing all the heavy lifting. And get this, the numbers here are just mind-boggling. Look at the red blood cells, the erythrocytes. We are talking about 5.5 million of them in a single cubic millimeter. That's a space smaller than a pinhead. They completely dominate the workforce. And their design is just ruthlessly efficient. That unique biconcave or donut-like shape gives them the maximum possible surface area for swapping oxygen and carbon dioxide. But here's the wildest part. To make more room for hemoglobin, the protein that actually carries the oxygen, mammalian red blood cells literally ditch their own nucleus. They sacrifice their ability to repair themselves and live longer, all for maximum cargo space. Next up, we have the defense force, the white blood cells. Now, these are the true, complete cells of the blood, nucleus and all. And they're not just one thing. They're a whole coordinated team. As you can see, the most common are the neutrophils, your first responders that literally gobble up invaders. Then you have the all-important lymphocytes, your B and T cells, that handle targeted, long-term immunity. And you've got others, like the monocytes, that act as the heavy-duty cleanup crew. Each one has a very, very specific job. And finally, we've got the tiniest members of the crew, platelets. Funny thing is, they aren't even really cells. They're just little fragments that break off of massive cells back in your bone marrow. But their job? Absolutely critical. They swarm to the site of an injury and form the first plug that literally stops you from bleeding out. Okay, so we've got this incredible high-pressure, high-speed highway system. It's fantastic for bulk delivery, but that very system creates a new problem. What about the last-mile delivery? Right? How does the oxygen actually get from that super-fast highway to the individual houses, the cells? And who handles all the local cleanup, the waste collection, the neighborhood watch? The main highway is just too big and too fast for that kind of delicate local work. This is where our second hidden network comes into play. This quote from the source material is, without a doubt, the single best definition of lymph you will ever find. It's so elegant. Lymph is what you get when you take blood and just remove the red blood cells and the big proteins. That's it. This simple subtraction explains everything about what lymph does and why it's so important. So here's the journey step by step. First, the intense pressure inside the blood capillaries literally squeezes some of the plasma out into the surrounding tissues. This fluid then bathes all the cells, dropping off the groceries and picking up the trash. Then a whole separate network of lymphatic vessels collects all this fluid, which is now officially called lymph. This lymph gets filtered through your lymph nodes to screen for any bad guys, and finally, the clean fluid gets dumped right back into the bloodstream. It's a beautiful, continuous loop. But wait, there's more. Lymph has another critical job that blood absolutely cannot do. The dietary fats you absorb from your food, they're way too big to squeeze into the tiny blood capillaries, so they have to take a different route. They get picked up by special lymph vessels in your gut, which means lymph is the only transport system for fats and all those crucial fat-soluble vitamins, A, D, E, and K. Without this hidden network, you just couldn't absorb them. So when you put it all together, you realize these aren't two separate competing systems. What you have is one single brilliant system with a perfect division of labor. Blood is the high-pressure, high-speed highway. Its job is bulk delivery, especially for oxygen. But it desperately needs lymph to be its low-pressure service road, the network that handles the delicate local exchange, the constant cleanup, the immune surveillance, and of course, that exclusive fat transport contract. It's a perfect partnership, and it all goes back to that simple difference in their composition. So the final thought I want to leave you with is this. The body's elegant solution to its massive logistics problem was to create a second parallel system by simply leaving the heavy cargo behind. By shedding those bulky red blood cells and large proteins, it created a fluid that was nimble enough to seep into every nook and cranny, handling all the delicate local jobs that the main highway is just too big and clumsy to do. It's not just two systems working together. It's one beautiful design solving two very different problems